Okay, so I just wanted to give you some more examples on this guided practice. This is all on page 36. So what I did was I found the exponential rules on the internet, and I just put them down on here so I can refer to them. So to have these right in front of you is probably really, really helpful. So let's start the first one. 8 to the negative first power. So I have a negative exponent. So looking through here, here's my negative rule. And so if I have something that's a negative exponent, they give me an example of how to write it. And then they give me a numerical example. And I can follow this along. So A would be the 8. Doesn't matter what the base is. It can be a letter, it can be a number. And it shows me to write it as a fraction, taking away the negative. So I have my base and the exponent. So the very first one, the answer is going to be 1 over 8, 1/8. Now there is an exponent there of a 1, but we don't write ones. We just assume that they're there if we don't see them. It looks like problem number 2 is the same way, where we have a negative exponent. So what we're going to do is we're going to use the reciprocal of 6 to make it 1/6, and then keep that exponent. So notice that a 1 is automatically understood. We don't have to write it. But a 2, we have to write that. Next, we have the 0 power. And here's the 0 rule. So anything raised to the power of 0 is automatically a 1. This is going to seem weird, but I came back to this page because I realized I didn't finish this problem. It says find the value of each power. So I have to do 1 over 6 times 6, and that would simply equal 1 over 36. So that would be the answer for problem number 2. Sorry about that. Wasn't thinking. Okay, so once again, 10 squared. Now 10 squared simply means 10 times 10. So you have 10 down once, twice, because there's a 2 here. What's 10 times 10? 10 times 10 is 100, so the answer is going to be 100. For the next one, we have 5 to the 4th power. That simply means 5 times 5 times 5 times 5. So 5 times 5, let me move this out of the way, I think. Whoops, doesn't want to separate. Okay, 5 times 5 is 25. This 5 times 5 is also 25. And you do have a handy dandy calculator. And if you multiply 25 times 25, you get 625. So 5 to the 4th power is 625. Okay, the next one. Notice how we have a negative exponent here. So what we have to do is rewrite that as 1 over 2 to the 5th power. Now that means 2 times 2 times 2 times 2 times 2 in your denominator. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that would be our answer for number 6. Okay, so problem number 7, we have this negative exponent. Remember, take a negative exponent and write it as a fraction. Use the reciprocal. So this one's going to be 1/4, and that's raised to the 5th power. So that's simply going to mean 4 times 4 times 4 times 4 times 4. So that answer is going to be 1 over 1,024. So make sure you know how to do those problems. Okay, real simple problem with number 8. There's that 0. You're going to love the zeros. No matter what your base is, you're going to always make a to the 0, whatever the base is to the zeros, automatically a 1. So the answer to this is 1. Okay, number 9. On number 9, we're going to have 1 over 11 to the third power. Because we have this negative exponent, I'm using the negative rule and I'm writing it as a fraction first. Then we're going to have 1 over 11 times 11 times 11, and that's going to be 1 over 1,331. And that will be the answer to problem number 11. So having this exponential rule really helps out a lot, having this in front of you. Okay, this one, it says use properties of exponents, and here they are, to write an equivalent expression. So here I have 4s. I have 1, 2, 3, 4. Maybe I should make this a little bit bigger and just shove this around. So I have 3 4s, so my exponent's simply going to be 3. I have 4 to the third power. And I'm going to scooch this over. And here I have 2 2s and I have 3 2s. So I have 2 2s, so that'll be a 2. Here I have 3 2s, so this exponent will be a 3. And then using my rule, I'm multiplying these base 2's together. So product means to multiply. So it tells me if I have 2 exponents and I'm multiplying the bases, I simply add. So this will be 2 to the 5th power. So I'm still using my exponential rules. Let's go to number 12. So on problem number 12, we take 6 to the 7th power, and they wrote out all 7 of those 6's. Then 6 to the 5th power, they wrote out all 5 of those 6's. And they want you to simplify it. Well, if I look at my rules of when I'm dividing, the quotient rules, it tells me to subtract the exponents. So I'm going to keep my base of 6. And then 7 minus 5 equals 2. So my exponent is 2. Another way to show this is to simply match these up and cross them off. And I do end up with 2 6's. So either way will work. Okay. I'm using my exponential rules here. I'm not sure what's going on, but you know, that's technology. All right, so here we are. 8 to the 12th divided by 8 to the 9th. Here they have a much shortened version. They just want you to show that you're subtracting those exponents. So let's show that we're going to take 8 to the 12th minus 8 to the 9th, and that's going to give me 12 as my base. Nope, pardon me. What am I thinking? That'll keep 8 as my base, and then 12 minus 9 gives me 3. And so the answer is 8 to the third. So try these 4 using the idea that we just had in the last 4, and then come on back and I'll show you what the answers are. Okay, so let's come back with some answers here. And so this one is 5 to the 10th power times 5. And see, you don't have any little exponent up there, so we automatically know that that's a little 1. Whoops, maybe I should make this bigger again. So automatically know there's a little 1 there, and this 5 doesn't have an exponent that I can see, so it's automatically a 1. And so what we're going to do now is take 5 to the 10th times 5 to the 1st times 5 to the 1st. That'll be 10 plus 1 plus 1, and that'll end up to be 5 to the 12th. Remember, if you're multiplying, you add the exponents. Okay, let's move this over. Here we have multiplying again. So this is going to stay as a 7. And then 8 plus 5. What's 8 plus 5? 13. So 7 to the 13th power. Now they're not asking you to find the value, so that's easy. All right, let's move back over to problem 16. Okay, 16 looks like it needs some more space. Okay, so let's see. On 16, they have 6 to the second and 4 on the outside. So what do you do if you have these two? If you have two powers and one base, that's your power rule. So what happens is you multiply them. You multiply them. But they want you to do all these steps. So let's fill their steps in. So I have 6 squared, and there are my two 6's for 6 squared. But this power hasn't been used. So that power is going to remain 4. And then they come down here and they say, I have 4 groups of 6 times 6. So here's one group, here's a second group, this will be our third group, and this will be our fourth group. I don't think they explain this very well, but that's okay. We will make our way through this. So there's all 6 groups. So I got 1, 2, 3, 4, 5, 6, 7, 8. I have 8 6's multiplied together. And you could have gotten that from 2 times 4. So your base stays the same as a 6, and you have 8 of them multiplied together. Again, you could have easily done that with 2 times 4, but they made you do all these steps. All right, let's go over here to number 17. And it looks like they're going to do steps here again. Whoops, why didn't my numbers go with that? Huh, I don't know why they didn't go. I'm going to have to get rid of them. Okay. I don't know why they didn't go along. Alrighty. So here we have 3 as a base, raised to the third power, raised to the third power again. So they take the 3 3's on the inside and they make 1, 2, 3. And here's the power on the outside we haven't used. And then they want us to write these out. So what you're going to end up doing is you're going to have 3 times 3 times 3 times 3 times 3 times 3. And that's going to give you 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spaces here. And so what I'm going to do here is put in 3 to the 9th power. And of course, you could have gotten that by 3 times 3 gives you 9. Keep your base of 3, and then there's your 9 exponent. So there are a lot easier ways to do this than write everything out. So. Okay, so these are going to be solved by using order of operations. And I'm going to give myself some space here. I'll scooch that one over later. So order of operations. So I'm going to do the parentheses first. Parentheses first. So 10 minus 6 is 4, and that's to the third power. We still have 4 squared plus 10 plus 2 is 12, and that's squared. And then next comes exponents. So you want to calculate 4 to the third power. So 4 times 4 is 16, times 1 more 4 is 64. 4 squared is 16, plus 12 squared is 144. Okay, so next we're going to do multiplication. So this is why you have a calculator. 64 times 16, that'll be 1024 plus 144. And then add 144 to that, and you get 1,168. So 1,168. So it's important that you use order of operations on these. All right, so I'm going to scooch over. See, I'm scooching, but not everything is scooching with me. I'll just scooch it on its own. All right, so give this a shot and then come on back and we'll look at the answer. Okay, so once again, you're going to be doing order of operations. So the parentheses come first on the top. So 12 take away 5. What's 12 take away 5? Okay, that'll be 7. That's still to the 7th power. Now down below, do the innermost parentheses first. So 3 plus 4 gives you 7. And that's squared. And the outside is squared. So I'm going to work to the right here because it's kind of hard to go downwards on this one. So keep your numerator. The denominator says you have a base with 2 powers. That'll be 7 to the 4th power. Now keep in mind your rules that you had. When you're dividing and you have the same base, remember what you do with the powers? So in division, fractions are fancy divisions. Same base, you subtract the powers. So this is going to be, this is going to be equal to 7. The 7 take away 4, you subtract. That's 7 to the 3rd power. So 7 times 7 is 49, times 7 is 343. 343. Now you definitely could have used your calculator to figure out that value and figure out this value. And then since fractions are fancy division, divide, and you would still get 343, but your numbers would be pretty large. Your calculator may not be able to handle them. Okay, one more. Okay, so here are the exponential rules. It's going to help you with this problem. It says summarize the rules for multiplying powers with the same base. So multiplying powers with the same base, that's your product rule. Dividing powers with the same base, that's your quotient rule. And raising powers, a power. Power to a power, that's your power rule. They want you to summarize these rules. So take a minute and try it, and then I'll be back. Okay, so welcome back. And what I have down here is when I'm multiplying the powers with the same base, I add the exponents. When dividing powers with the same base, you subtract the exponents. So here's dividing and I subtract. When raising a power to a power, that's the power rule, you multiply the exponents, and they show you that you're multiplying. That's all there is to it.